Hello, so today continuing on Leetcode contest 167, we are going to take a look at this problem called sequential digits. So the problem says we have an integer that has sequential digits if only if each digit in the number is one more than the previous digit. That means basically, if we look at this example 1, 2, 3, 2 here is just the previous number plus 1, and 3 is just the previous number, which is 2 plus 1. And the goal here is to return a sorted list of all the integers in the range low, high, inclusive that have sequential digits. So for example, here we have low equal to 100 and high equal to 300, and the goal is to return the numbers in this range 100 to 300 that have sequential digits. And so the only ones we can find in this range are 1, 2, 3 and 2, 3, 4. And a similar example here. And low and high can be between 10 to 10 to the power of 9. So you can see it's very big numbers. Now let's see how we can solve this problem. Okay, so let's see how we can solve this problem. So one of the examples we have is, just to keep this in mind, is this example where we have low equal to 100 and high equal to 300, right? And the result that we should return is 1, 2, 3, which you can see 1 plus 1, 2, 2 plus 1, 3, and then the other one is 2, 3, 4, right? So if we think a little bit about this problem, there are two possible ways to approach it or to think about it, right? So one of them is, well, we could just generate all numbers in the range low to high, right? And then just check if sequential, and then if it is, added to the result, right? That's one possible way to approach it. But you can see here in the constraint we have that low and high are between 10 and 10 to the power of 9, so it's very big. So we shouldn't like explore all this range, right? So maybe we have one instance which is from 10 to like 10 to the power of 9, and this is too big to do linearly and each time do the sequential check, right? Because 10 to the power of n, that's n numbers, are going to check each digits, right? So this one doesn't look promising. The other way we can do this is, well, generate all sequential numbers, or numbers that have sequential digits, from 1 to, or from either 1 or 10 to until we reach high, right? Until we reach high, because after that we are not interested in them until we reach high. And then add to results all of those that are bigger or equal to low, right? That are bigger or equal to low, right? So this is one way to do it, right? And definitely this one looks promising, because we know that the numbers, like for example from 1 to 300, we just have 2, right? So we wouldn't need to try all of them, because the number of sequential numbers is very limited. So this one looks more promising. Now, how can we generate these, right? So one way to think of it is, well, let's just start from 1, right? So the possible ways for these numbers to be is that they can either start with 1, or start with 2, or start with 3, until they start with 9. That's all the digits we have. We start the digits that the number can start with. It's just this range here, right? It can't start with another digit. That's the only digits we have. And then now what we can do is, okay, check when we start with 1. Well, let's just take the number to be 1, and then, okay, take 2, take 1 plus 1, so that 2, and then after that take 3, after that take 4. So construct it in a way that it has only sequential digits, and do the same thing for 2. So number is equal to 2, and then we'll add 3, we'll add 4, and we'll add 5, and each number of these digits, we'll start exploring it, and we will stop when we reach high, right? Stop when number is bigger than high, because we don't want these numbers, right? And so how can we construct this succession here, the sequential digits, right? So one way we can do that is just have some next variable, right? So just have a variable called next that we increment each time, right? And then each time we increment, we will make the digit to make the number be something like 1, 2, 3. What do we need to do? We can use the formula that number is going to be number which multiplied by 10 plus the next value, right? So for example, in the first iteration here, we would have number equal to 1, and then we would have next that was equal to 1. We will increase it by 1, right? And so now next is equal to 2. And now this formula, if we plug it in it, we would have num is going to be 1 multiplied by 10 plus 2, which is going to be 12, which is this portion that we are looking for. And then since low, in the first example that we have here, low is equal to 100, so it still is not less than not bigger than low, so we don't add it. This is not valid yet, and so we keep trying again, and so we do next plus 1 one more time. And so if we do one more time next plus 1, that's going to be next is going to be equal to 3, and we will plug in the formula again, which is num is equal to now 12 multiplied by 10 plus 3, which would give us 123. Now if we check if num is bigger or equal to low at this point, that's true because low equal to 100, so we can add to the result and add the number because it's valid. And then after, when we try 4, right, so when we do the next iteration and try 4, now the number that we will get is going to be 1, 2, 3, 4, which is bigger than high because high is 300, and so we'll exit. And then when we exit, we'll go to the next digit, starting with the next digit, and we'll try this digit as a start, and we will do the same thing. And then we'll have 2, 3. That's not bigger or equal to low, so we'll try 2, 3, 4. That is bigger than or equal to low, so we'll add it. And we try the same thing with 3. So we try 3, 2. That's not bigger or equal to low, so we'll try 2, 3, 4, 5. That's bigger than high, so we exit. So you get the idea. This is the way we are going to generate them. And so you could see here, at most we will go through each digit, and as soon as it's bigger than high, we will stop. So bigger than high, we will stop, and that are bigger. So when the number is bigger or equal to low, we will add it to the result. So these are the main points that we are trying to do. So one of them is, this is the generation part, right? And then we have the second part, which is adding to the result, and the third part, which is exiting when we reach high. And so let's just write this in a more clear way. And so what we need first is to go through the digits, and so to do that, we are going to say, okay, for digit in the range of 1 until 9, so to stop at 9, we need to do 10 in Python. That's how it works. And we all start with the number being equal to digit, right? And then the next number starts out as digit, but we'll keep increasing it as we go along. And so next we will keep going while the number is less than high or equal to high, because as soon as it's bigger than high, we want to stop. So that's what I'm doing in this while loop. And here I'm going to keep increasing next, but once I reach 9, I don't want to increase it again, right? Because then it's no longer one digit, right? And so what I'm going to do here is going to say next while it's less than 10. And so we are going to do this check here to add it to the result. I can do it at the end, but I just prefer to do it here so that the case where it's just the value is just 1 gets handled, right? And so I'm going to do here if the number is bigger or equal to low, so that means it's a valid solution, we will add it. Since we are generating only valid numbers, we can just, if it's bigger than low, that means it's a valid solution, so we just add it, right? And so we add that number. Then after that, here we will do the next plus 1 and this operation here. So we'll do this operation and next plus 1, right? So that would mean here we would say next plus 1, so that it's the next digit, and then the number is going to be number multiplied by 10 plus next, right? So that when this is 1, we will multiply it by 10, and then when this is, because we incremented, it's 2, we will get 12, right? And the same thing when it's 12, we multiply it by 10, and then we'd add 3, we'd get 1, 2, 3, right? So we construct them in a way that they are sequential. And here, if we need to do this part where, this part we already did it, so we can just return at the end, we can return result. There is just one caveat, which is that the problem asks us to return a sorted result, so we just need to sort this one. So we just need to do sorted result. And that's pretty much all there is to it. So let's plug this in and see if it works. But essentially what we are doing is just take all the possible digits that can be a start of a number, and then try each one of them and generate them in a way that the digits are sequential, and every time that it's in the range, which means that it's bigger than or equal to low, and since we maintain that it's less than or equal to high because we exit if it's not, we add it to the result, and that's pretty much all there is to it. So yeah, let's try this. Okay, so let's try the solution that we just mentioned. So the first thing is that we need the result list, and then we need to go through the digits, and so that would be a range of 1 to 10, and we need to have the number, right, which starts out equal to digit, and the next number, same thing, starts out equal to digit, and while we maintain that it's less or equal to high, and that the next one is still in a valid digit, we are going to check if it's in the range, because it's less than or equal to high. If it's in the range, which means bigger or equal to low, we add it. This will be done in each iteration for the previous number, right? And so we could have done it in the end, but I just prefer it this way. And then we would say the next, so this here allows us to have only sequential digits, and we calculate the new number using that next digit, so multiplied by 10 plus next, and at the end we can just return sorted result, and that's pretty much all there is to it. So let's run this. Okay, looks like it's good. Let's run it with another example, say this one. Okay, looks good. Let's submit. Okay, so that passes. In terms of time complexity for this solution, we do like explore all the 10 digits, right? And then we do up until some number of sequential numbers, which would be probably like a base 10 of high, right? Because when we reach high, we stop, right? Here, when we reach high, we stop, and so you can see here it's a lot better because like 10 of a big number. So is there log in Python? Log. Yeah, I'm not sure, but yeah, like 10 is a lot smaller than the high number itself, right? And in terms of space complexity, what we are doing here is we are using just this result list, which at most would be the number of sequential numbers, so it won't be bigger than, same thing, 10 log 10 of so it won't be bigger than log 10 of high, right? And yeah, so that's pretty much it. We can probably find a way to make this a little slightly better to not explore all those less than low, but I think this is good enough. Yeah, so that's it for now. Thanks for watching and see you next time.